What's going on, folks? It's Mike here, and in this lesson, we are going to be revisiting a topic that we have talked about before, and that is const. And we've looked at one use as a qualifier to make a variable read-only. So I'll recap that, and then I'll talk about a second use where we pass an argument as const and why that's important to do and worth our time in this lesson. So let's go ahead and dive into the video here. So just as a quick recap in this lesson here, I'm going to go ahead and recompile this code, or at least attempt to recompile this code. You'll see that x here is an integer, it's marked as const, and if I try to modify it, well, that causes a problem because this variable is read-only effectively when we make it const. Now, something that might be worth your time doing, and just to add a little bit more value for folks who have seen this, is to search const on the CPP reference website. Again, that is just in the search box in the top right corner there. I've searched const, and you can see some of the uses here to recap. And I thought something that maybe is less known is you can check if the actual data type is const here in the type traits library. So let me go ahead and include type traits library, and we can do a check here just to see if the type is const or not here. So just to make very clear, and in case you are using types that have been declared by other users and just aren't sure. So I'm going to comment this out here and go ahead and run it, and you can clearly see that, well, when we qualify with const here, this is a const type. Now, if you want to know if x itself is a constant variable when you're using it in your code, or perhaps you're reading somebody else's code, you can try doing a little bit extra work here. And this is something I don't want to introduce too much of, but what I'm going to do is copy this here. Let me go ahead and add a line here, and you can use something known as decal type, which I'll bring in here, inspects the declared type of an entity and the value category of that expression. So what exactly it is evaluating to. So let me go ahead and just check, instead of providing the actual type, do decal type. And again, this is a C++ 11 feature, as you can see from the reference here. And then what we're going to need to do is pass in our variable x here and retrieve the value. So again, how do we figure that out? Well, we can sort of read through this documentation, but let's go ahead and just give this a try here by compiling and just making sure that our brackets are in the right place here so that we are retrieving the value. So let me go ahead and rebuild. And we are getting some error messages here. So I want to leave this here because it's actually saying that this _v is not the right or the actual thing that we need. Because if we go into our is const here, well, we have is const itself, this inline expression here, which is wrapping just is const with the value here. So let me go ahead and get rid of this inline version here. Go ahead, rerun this, run the program, and now we can verify, well, we got a 1 for true here, that x itself is a const int, so some constant type. Okay, so cool. We can do some cool or interesting things with const here. And that's a little bit of a recap of last time with some bonus material here. So I'm actually just going to comment this out here and bring us to one of our previous lessons where we are learning about pass by value and pass by reference. So why does this matter, or why do we really care about learning about const here? And I'll go ahead and just put the whole code here. Because oftentimes, if we're passing in a big collection of data, as we're doing with this pass by reference, in fact, I'll get rid of the pass by value. We don't really care about that. What we'll want to do is pass in a parameter that is this whole vector of, I think, well, exactly 1 billion elements into some function. And if we're going to do this often, but we know we're not going to mutate any of the data, or if we want to prevent the client, somebody using this function, from manipulating the data, then we're going to just simply make a const in front of the variable, and then this data cannot be changed. So it's going to be efficient because we're passing by reference, so we're avoiding making copies, and we're passing safely because we're not modifying any of the data coming in. So for example, here we are trying to modify some data. So let's try to recompile this program. And again, we're going to get this error, assignment of a read-only location. So let me just comment this out so that we're not modifying or reassigning any of the data. And now this will compile and run. So that's the next use of const that we've learned about to make it safe to pass data between functions and ensure that we're not changing the data. So with that said, we've learned about two uses of const. Again, it's a qualifier that we can just use on regular variables. And secondly, we can use it on our parameters for functions when we're passing them in, just like we would as variables, whether it's a reference, whether it's a pointer when we learn about that, or whether it's just a regular value that we're passing into our function. And again, this is for safety and to ensure that programmers aren't misusing our functions, or we ourselves aren't misusing functions, and have a guarantee that data passed in can be read but not modified. All right, folks, so this is a super important lesson because it's going to really enhance and make your code better if you make this decision about whether your data is read-only or is able to be modified. So I hope you do take this lesson, practice the examples here, and of course, look out for more lessons in the future by liking and subscribing. And we'll see some more uses of const in the future as well when we talk about classes. All right, folks, we'll see you in the next one. Stay tuned.